Recent research has found that AI-assisted coding is perceived to improve the performance of the software development process, and for some companies, that is actually true. However, for most companies, AI-assisted coding could actually be quietly backfiring. I'm Antony Marcano, and my track record is in taking companies' software development capabilities to the top of the scale of industry performance benchmarks, with or without AI. Google Cloud's 2025 DevOps Research and Assessment State of AI-Assisted Software Development Report is the result of a research initiative across thousands of respondents from companies around the world. And the key finding in that report is that AI-assisted coding magnifies the strengths of high-performing organizations and the dysfunctions of struggling ones. Now, of course, our egos will always get in the way of believing the latter part of that statement could ever apply to us. But the data in this report actually suggests that any company that truly wants to succeed with AI-assisted coding will actually start to question that. But before we actually get into that data, let's briefly talk about exactly why AI can actually make things worse rather than better. And a friend of mine and esteemed colleague, Jason Gorman, has actually put this really succinctly, that the key to being effective with AI coding assistants is actually by being effective without them. So to better understand that, let's look at a common yet underappreciated phenomenon affecting many organizations, which I've actually talked about for years, and you'll find me relate that to AI on LinkedIn quite some time ago. So if you're not following me there, I'm sure you know how to solve that problem. However, let's understand this phenomenon with the help of Little's Law applied to a scenario we all understand. Traffic. Let's imagine a two-lane road that approaches a single-lane bridge that crosses from Devland to Productionville. I'm sure you can understand exactly where I'm going with this. Now, cars along that road have to cross the bridge in order to get to the other side. And generally speaking, all the capacity of that road will be filled up with other cars, or in the case of your development team, other work. Little's Law helps us understand work in progress, average throughput, and the average time an item spends in the system. So if we know the work in progress and the average throughput, we can actually calculate the average time the item will spend in the system. In order to set a baseline for our illustration, let's assume that one vehicle leaves the bridge every minute. That's our throughput. And, of course, there's capacity left in our team or left on our road, and another vehicle joins the queue. Because we know that there are 10 items in process, Little's Law tells us that it will take 10 minutes on average for any vehicle entering that system to exit the other side. So when we add AI coding assistants into the mix, developers can essentially get through more work more quickly, and that's the equivalent of increasing the capacity of the team. In this case, adding 5 more vehicles into the queue. Now, again, because we have 1 vehicle per minute crossing the bridge, that's our throughput, we now have 15 vehicles in process, we can now calculate that it's going to take 15 minutes for every vehicle to enter that bridge and then leave it. And that's because AI-assisted coding will increase the output from your developers, but it doesn't do anything to address the bottlenecks that might have restricted the flow of new capabilities into your product out in production. That could be blocking pull requests, manual testing, all sorts of other things that could be causing this particular issue. So while it might seem counterintuitive, by increasing the rate at which developers can ship new code, you're actually making everything go slower. Another finding in the report is that using AI coding assistants actually increases instability in your software development process. And by instability, they mean things like the rework rate. Unfortunately, what that's going to mean is our overall throughput is likely to slow down because slightly more work is going to have to be rejected from the bridge and sent back into the system for rework. For the purposes of our illustration, let's assume that we're going to have a 10% reduction in our throughput, resulting in a 0.9 vehicles per minute crossing that bridge. And again, because we have 15 vehicles on the bridge, instead of it taking 15 minutes, which was already more than our original 10-minute baseline, it's now going to take 16.7 minutes. Now translate that to the units that are relevant to your software development process, whether that's days, weeks, or months. One of the choices I've seen many organizations make when they don't realize that they've got this bottleneck is actually to just keep taking on more work with the developers. And that results in even more items in process, waiting to get across the bridge, resulting in even more time taken to complete the work. And many teams will keep going with that until eventually they stabilize at a certain amount of work in process, simply because for the rework that's coming back through the system, that limits their capacity to take on any new work. And it's that stabilization that might have given us the baseline that we had in the first place. Now, with the ability to generate more code, or in this example, get more vehicles onto the road, we're actually going to still make things slower. And the end result is product managers getting frustrated that it's taking so long for any of their work to find its way to the top of the backlog, let alone even get through the system and deployed into production. But what if your goal isn't to increase your throughput? What if your goal is to maintain your existing throughput, but by spending less on software developers? So let's go back to our baseline of 10 vehicles taking 10 minutes before AI is introduced. Well, again, as I said before, the report found that instability in our software process is increased when we add AI into the mix. Well, as I said before, let's just assume an approximate reduction in throughput of around 10%, back to 0.9. Now what's happening is that we're going to take slightly longer to ship those products. And that hit might be something you're willing to take in order to reduce your overall spending on software developers. However, the same phenomenon will still tend to happen, where those developers will take on more work until eventually the system stabilizes and eventually everything still takes longer. So how do you tell if any of this is likely to be affecting you? Well, one of the tools at your disposal is actually a cumulative flow diagram that can help us understand if there's a bottleneck, how much it's affecting us, and where it probably is. Another option is value stream mapping. If you've got more questions about those, drop me an email via the information in the description. In the report, however, it gives us some ways to understand both throughput and instability in our software development process. For throughput, we have lead time for changes. So this is the time it takes for a commit that's made to the version control system, or a change that's been committed, to find its way into production. That could be as much as months, or it could be as little as minutes. Then we have deployment frequency, so the number of deployments over a given period of time. And that could be one deployment every month, it could be one deployment every week, or it could be multiple deployments per day. And then we have failed deployment recovery time, so the time it takes to recover from a deployment that fails and requires an immediate intervention. For instability, as opposed to recovery time, we have change fail rate, and that is the ratio of deployments that require immediate intervention following a deployment. And finally, new in 2025 in the State of DevOps report is rework rate, so the ratio of deployments that are unplanned but happen as a result of an incident in production. Now, before you start thinking you have to measure all this data across all your teams, actually there's a much simpler place to start, and that's by using the DORA quick check. Now, this allows you to ask a series of questions and then it generates a report showing you roughly where you score. Now, this doesn't yet have the fifth metric introduced in 2025 of rework rate, but it will give you a rough indication of where you sit on the scale. And by changing the drop-down box at the top to match your industry, you can see how you're doing against your competition. This report shows the actual results of an assessment for teams that I've actually helped establish and grow and develop over the last few years for my clients. And most recently, that has been in a large multinational corporation where you would imagine it simply wouldn't be possible. However, for most companies, being at the top of their industry is more than enough because that allows them to actually thrive against the competition in their sector. So for the teams I've worked with, AI can actually increase their capacity and therefore their throughput. Although I think the reality is that it's not just that their pathway to production wasn't constrained, because their lead times to change was around 20 to 25 minutes with about 15 to 20 deployments per day. So it's not just that they're not constrained on the pathway to production, it's that they're actually going at a higher top speed. Let's not overcomplicate the analogy because I've intentionally tried to keep it as simple as possible. Now, back in the State of AI-Assisted Software Development report, there's actually a breakdown of the distribution of the capabilities across all of their respondents. And they observed that there were 7 separate clusters, with clusters 6 and 7 being the highest performers. And if you remember the quote from the report earlier in this video, it's the highest performers that are going to benefit from AI. So clusters 1 through 5 are much more likely to have the shortfalls that they have compared to the highest performers amplified by using AI. And they represent 60% of the sample. At a conference I recently spoke at Cambridge University, where multiple companies were represented, during my talk I did my own little survey to see which ones fell into the higher performers and which ones didn't. And the highest performers were only represented by around 4% of the room. And I think this is because the respondents to this study are already interested in what DORA has to say. And therefore, the people who aren't aware of the work that DORA does and the research that they provided to help us understand what high performance could look like are less likely to have responded to this survey. So my estimate would be that it's more likely 75% of companies fall into clusters 1 through 5, and only 25% of companies and teams actually fall into clusters 6 and 7. So the bad news is that statistically, you're much more likely to be in clusters 1 through 5, and that might suggest that you could have adopted AI-assisted coding too soon. But the good news is you can actually turn it around. So let's go back to our traffic example, because whether your goal is to increase the capacity of your teams or lower the spend you have on software developers, the solution to your problem is exactly the same. and that is to reduce the work you have in process. So going back to this example, the time that it took for a vehicle to get through the system was 11.1. What we really want to do is limit the work in process so that we reduce the number of vehicles going across that bridge, or in our case, reduce the amount of work that the developers are doing, so we can reduce the overall time it takes to get an item from the backlog to production considerably. And all of that unused road represents the spare capacity in your development team, which can then be focused on trying to figure out how to actually widen that bridge in order to increase the overall throughput of the team that you already have, and in a way that allows you to scale that out. So as AI assisted coding becomes even more sophisticated and makes your teams go even faster, you can get more and more throughput out of your software development process. And your team's ability to achieve this and the results I showed you earlier will depend significantly on how skilled they are in what many would call agile software engineering practices. So that's some of what you could do. If you're uncertain about how to do any of it in a way that will succeed in your context, or you've already tried and was met with resistance, well, these are the kind of problems I help people with. So feel free to get in touch via the details in the description of this video. However, if your teams are already doing all the practices that should yield the results I've spoken about but haven't yet, the answer to that is in this video here, link in the description. I'll see you there or here. Thanks for watching.